Let's talk about the first of the two main climate engineering methods, marine cloud brightening. Now here we've got a satellite vision of a region of the ocean. There's some thick clouds over here, and over here you can see there's some patchy low altitude clouds. But what you can see is all these thick white trails where the clouds are much thicker. These white trails, you can tell that more sunlight has been reflected. That's why they look white. Whereas in between it's darker, so the sunlight is getting through to the sea. So whatever is causing these white trails, it's actually helping reflect sunlight away and therefore making the ocean cooler. And what's causing it? Well, it turns out it is big cargo ships. Now, tens of thousands of these huge cargo ships are constantly moving across the world's oceans, delivering goods from one country to another, oil, cars, containers, grain, what you name it. And they typically burn low-grade diesel and bunker fuel, and that produces lots of pollution. Now these white trails are not made of pollution, however, and pollution is nothing like enough to make trails like this, even if it was white. These white trails are actually just water vapor, like any other cloud. They're droplets of water vapor. So how does a ship belching out pollution produce more water vapor clouds? And the basic idea is nucleation. Let's imagine you have some body of atmosphere which is super saturated with water. The water is just wanting to come out and form droplets. But to trigger this, it often is very helpful to have a nucleus, a tiny solid something. Once that's there, the water droplets can condense around it. Now on land there are almost always plenty of these tiny dust particles in the atmosphere to act as nuclei, so clouds have no trouble getting started. There's dust and things blown off from the ground and so on. But deep in the oceans, it turns out that the air can be very clean. There are very few of these grains. Sometimes you get a dust storm that blows smoke or something off the land, but most of the time there are very few grains in the atmosphere. What grains there are, water will form around, but because there are only a few, you get large amounts of water forming around a few of these nuclei, which gives you a few big droplets, which gives you a mostly transparent cloud, because it doesn't block the radiation very much. But let's imagine you can somehow pump large numbers of tiny grains into the atmosphere, maybe sulfur dioxide from your noxious pollution from your ocean tanker, like what's belching out there. Now you've got a lot more condensation nuclei, so you can get large numbers of smaller water droplets forming. Same amount of water condensing, but now it's going to form around every droplet. There are going to be more of them, so you get huge numbers of smaller droplets. And this blocks the light much better. Same amount of water, but it's much better at reflecting sunlight. So that gives us these white lines. It's thought to be that the belching stuff goes up there and acts as condensation nuclei, so the water droplets can form around it, producing much thicker clouds. And that's the basic idea. How would this work in practice? Well, it's been kind of happening accidentally, that you've got lots of ships belching stuff around, but that stuff you're belching is also pretty toxic. It causes acid rain and many other problems, and in fact a lot of that has been blocked by international regulation in the last 10 years or so. So in fact, the fact that we're blocking this existing form of pollution is good for anyone who has to breathe it, but actually bad for global warming and may be responsible for extreme temperatures seen in some heavy ship lanes in the last few years. So what we want is something that's not so toxic that we can spray into the lower atmosphere to act as nucleation points for clouds. And there are various possibilities, but one of the obvious ones is to just spray seawater up. The water will evaporate, leaving tiny grains of salt, which act as condensation nuclei, and that's natural, it's not going to kill anybody. So the natural concentration of condensation nuclei over the ocean is between 50 and 200 per cubic centimetre, and those are mostly ammonium sulfate particles produced from planktonic algae at the sea surface. What we want to do is raise it from that sort of 50 to 200 up to about 400 nuclei per cubic centimetre by spraying salt water into the air or producing lots of bubbles, which when they break and burst also can spray water into the air. And then the water condenses, leaving salt grains behind to form the clouds. And you can imagine doing this with fleets of solar or wave-powered barges cruising around, pumping up the salt into the atmosphere. And there's no obvious reason why it can't work. I mean, we know that pollution from ships works. The science is kind of accidentally proven. So it probably would work. But no one's really tried large-scale experiments. A few small-scale experiments have been fairly promising. But most estimates are that you could do this for much less money than decarbonising the whole world economy. So this actually might be quite feasible. Even if we don't do it for the entire world, we could do it for certain places. For example, this is one contender for how we might save the Great Barrier Reef. The Great Barrier Reef is being threatened by bleaching events that expel the algae from the coral because the temperature gets too high. Maybe whenever you see one of these things happening, you could send out a fleet of these barges to spray salt water into the air and enhance the clouds, and that could bring down the temperature by a few degrees and maybe save the Great Barrier Reef for another bleaching event.